Hi, welcome back to AT Math 12-6, Dividing Polynomials. Now remember, if you have 6a plus 4 divided by 2, you're going to divide both terms by 2, the 6a and the 4. So 6a divided by 2 and 4 divided by 2 becomes 3a plus 2. Simple. Now when you have a polynomial, it's the same thing. So 6a cubed plus 4a squared divided by 2a, you're going to divide both by 2a. So okay. 6 divided by 2 is 3, a cubed divided by a is a squared, 4 divided by 2 is 2, and a squared divided by a is a. Now when you divide a polynomial by a monomial, just like we did, you're taking all this and dividing by 2x. So basically you divide each one by 2x. This divided by 2x, this divided by 2x, and this divided by 2x as shown. As you can see, they're divided down. You get 3x squared, 4x, and negative 2. Something new. We're going to divide all these 3 by 6x, but take a look at what happens. So 8x cubed divided by 6x, 2x divided by 6x, and negative 12 divided by 6x. But 8 divided by 6, you just get 4 over 3. 3x versus 1, 2 went on top. 2 over 6 makes 1/3. The x's cancel. Okay, but here, negative 12 divided by 6 is negative 2. What's remaining? Because they both divide by 6, the x remains at the bottom. Notice how the x stays at the bottom. So your answer is going to be 4x squared divided by 3, which is this guy, plus 1/3, minus 2 over x. Now I know you don't like that much, but that's just how that is. That's your finished product, unless they give me what x was. Now you try 8p cubed minus 4p squared plus 12p, divide it all by negative 4p squared. Hint, divide all these by negative 4p squared. Go ahead at this time. Let's see how you did. Basically I split them up into 3 pieces, divide them all by negative 4p squared, which becomes negative 2p. This just makes 1, and this makes negative 3 over p, combines to that. You try again, 6x cubed plus 2x minus 15 divided by 6x. You're going to divide each one of these by 6x. Go ahead. Boom, boom, boom. X squared plus 1/3 minus 5 over 2x. Division of polynomial by a binomial is similar to division of whole numbers. Factor the numerator and or denominator if possible. Divide out any common factors and simplify. So basically you just did what I told you. You divide this by r plus 2. You can just take this first and split it into r plus 2 and r plus 1. These cancel, leaving just r plus 1. Same idea here. So if you split the trinomials like the last section. So c squared plus 4c minus 5 over c minus 1. We're basically going to break this down into c plus 5, c minus 1. c minus 1's cancel, leaving c plus 5. And 3x squared minus 10x minus 8 over 4 minus x. Now notice what they did here. They split these up into 3x plus 2 and x minus 4. Notice how that 4 minus x is flipped again. So we're going to times by negative 1 to put it back the correct way. These cancel, leaving 3x plus 2 over negative 1. Now I don't care if you leave it like that. I don't care if you make negative 3x minus 2 over 1 or negative on the side, as long as these values total out. You try, go ahead, 10 plus 7k plus k squared plus k plus 2. Hint, I would move these around and put k squared plus 7x plus 10. Go ahead at this time. Let's see how you did. These split up into k plus 5 and k plus 2, and this is all over k plus 2. Cancel, cancel. K plus 5. Again, if you were to worry about the exceptions, you would say k cannot equal negative 2. Since they don't ask, don't worry about it. You try. Take this, go ahead. Let's see how you did. Basically, you're going to break this up into b plus 7, b minus 7. This should have been a little 2 here, by the way. Not that it makes a giant difference, but it does to me. So b squared minus 49 over b plus 7, split, split. Cancel, cancel. b minus 7 is your answer. You try number 2, s squared plus 12s plus 36 over s plus 6. Go ahead and break it apart. Go ahead. Splits up nicely into s plus 6 and s plus 6 over s plus 6. You're only going to take out 1. Doesn't matter which one, but you're only taking out 1 for 1. So that goes away, leaving just s plus 6. Remember long division. Recall how you use long division to divide whole numbers as shown at the right. You can also use long division to divide polynomials, the example shown below. Remember how you do 23 goes into 34 one time, 23 34 minus 23 is 11. 5 comes down. 23 times 5 makes 115. Gives 0. That's your finished product. In that same way, x squared plus 3x plus 2, we can take x plus 2. You're trying to take, what do you times x by to get x squared, and that's x. X times x is x squared. X times 2 is 2x. Minus all that leaves 1x. Plus 2 comes down. X squared goes into x squared one time. That totals out as well. Use long division to divide a polynomial by a binomial. Write the binomial and polynomial in long division form. You know, I could read all these to you, or you could pause and read them yourself, but you won't see it till you do it. So let's just do it. Take it step by step. So x squared plus 2 plus 3x divided by x plus 2. Personally, I'd switch these around and put 3x in the middle. So x squared plus 3x plus 2 divided by x plus 2 on the outside. I need to take x times x to get x squared. So x times x is x squared. X times 2 is 2x. However, remember, you're not adding but subtracting, so x squared minus x squared goes away, and 3x minus 2x is 1x. The 2 comes down. Then x plus 2 divided by x plus 2, put a 1 in there. 1 times x plus 2 is x plus 2, minus out, and there's your answer. Another one, x squared plus 4x plus 3 divided by x plus 1. Now, you might say, okay, well, I need to take x times x plus 1 to get x squared, so x times x is x squared, x times 1 is x. Subtracting, x squared minus x squared goes away, 4x minus x is 3x. 3 comes down. 3x plus 3, I'm going to take 3 times x plus 1 to get 3x plus 3. That totals out. Now you try 2y squared minus 5y minus 3, all divided by y minus 3. Basically, we're going to go ahead and times this first one by 2y to get that going. Was this a you try? Oh, you try. Sorry, you go ahead and try. I'll pause. Alright, go ahead. So, you times by 2y here. 2y times y is 2y squared. 2y times negative 3 is negative 6. Notice I have a negative here, so I'm basically going to be switching the signs. So 2y squared minus 2y cancels it. And the negative makes a positive, so negative 5y plus 6 is going to be plus 1y. Put the negative 3 down here, so 1y minus 3. 1 times by 1. 1 times y minus 3 is going to be y minus 3. Cancel, cancel. Nothing left. So my answer is 2y plus 1. You try number 2. A squared minus 8a plus 12 divided by a minus 6. This time I'll actually wait. Go ahead. Pause. Let's see how you did. So a times a is a squared. A times negative 6 is negative 6a. Remember that they're actually minusing, not adding. So it's really just negative a and plus 6. These cancel. Negative 8 plus 6 is negative 2. Plus 12 comes down. I'm going to take negative 2 times a to get the rest. Negative 2 times a is negative 2 times a is negative 2a. Negative 2 times negative 6 is plus 12. Remember, we're actually minusing them, so the cancel leaves 0. Now, why do we have to do all this? I mean, because can it be solved like this? A squared minus 8a plus 12. Couldn't I just split it into a minus 6 and a minus 2 and cancel these two and get a minus 2? Why do I have to do all this long division stuff? Because this only works when there is an exact answer. When there is not, you have to use long division. This is the difference between Algebra 1 and Algebra 2. Algebra 1, they're all exact answers. You can go ahead and put them together, cancel out, you're done. Algebra 2, you need exact, and you won't always have exact answers. For example, 2x squared plus 3x minus 6 divided by x minus 2. Let's start with how we know. X minus 2, I'm going to take times 2x to get 2x squared. So 2x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. But remember, we're subtracting, so this is going to become a positive 4x. 3x plus 4x is 7x, right here. And then we're going to times by 7 to get 7x. 7 times x is 7x. 7 times negative 2 is actually negative 14. Very good. And we're going to be flipping the signs, remember, so it's negative and positive. It's going to be positive 14. So negative 6 plus 14 is going to be plus 8. 8's what's left. Now notice how there's not a convenient ending. It's not 0. So there's going to be 8, and it's going to be divided by x minus 2. So I have my answer here, 2x plus 7, but a remainder of 8. You remember years ago when they say put remainder up here? So 2x plus 7, remainder 8. That remainder just means it's being divided by whatever you were dividing by. So really it's 2x plus 7 plus 8 over x minus 2. And that's what you get. You see, learning how to do remainder actually had a purpose. You just didn't know it at the time. Here it is again. Divide 2x squared plus 3x minus 6 divided by x minus 2. I'll just walk you through it. Basically, they just did the same thing again. 2x times x, and then you get that, and times 7 times this. Basically, it's the same problem we just did, but you can follow with the book's example if it helps you. You can pause and look at it if you want. Alright, moving on. You try, go ahead. See how you did. 3m times m is 3m squared. 3m times 3 is 9m. Negative switches the sign, so the positive is going to become a negative, so it's going to be negative 5m. Negative 2 comes down. 3m. We're going to also take negative 5 times m then. Negative 5 times m is negative 5m. Negative 5 times 3 is negative 15. Switch the signs. Going to make plus 15. Minus 2 makes 13. And 13 will be divided by m plus 3. There's your finished answer there. You try again. Go ahead. Let's see how you did. So we're going to go ahead and take y squared plus 3y plus 2 divided by y minus 3. Y times y is y squared. Y times negative 3 is negative 3y. Switch all the signs. So it's positive 3y. 6y total. Plus 2 comes down. 6 times y is 6y. 6 times negative 3 is negative 18. But remember, we're switching the signs. Which is going to go ahead and make this plus 18, which makes 20. 20 is the remainder, and 20 over y minus 3. And there you have that. Now what if there's a 0 in the problem? Take a look at this one here. See, the problem here is you have negative 4x cubed, 3x, and negative 15, but you don't have any x squared. So in this case, we're going to put plus 0x squared. So that way you have x squared being represented. You have to have them in order. In other words, you have to have x cubed, x squared, x, and the non-x. You can't have it missing. It's not going to work. So we have 0x squared. And then you go as normal. You know, 2 times 2x squared times 2x is going to be x cubed, negative 4x cubed, so on. So negative 2x squared times 2x is negative 4x cubed. Negative 2x squared times 3 is negative 6x squared. Flip the signs, cancels. Positive 6x squared. 3x comes down. And then you go ahead and take times 3x to all this. 6x squared plus 9x. Flip the signs. And so this is going to become negative 9x. So positive 3 and negative 9x makes negative 6x. Negative 15 comes down. Negative 3 times all this is going to be negative 6x and negative 9. Flip the signs. Positive, positive makes negative 6 remainder. So negative 6 divided by 2x plus 3. So this whole giant problem is your answer. It's a lot. It's complicated. Take it step by step. Go ahead and try. Let's see how you did. This, first of all, gets put in the correct order. 0x is now represented as a single x. X minus 2. X squared comes out first. X squared times x is x cubed. X squared times negative 2x is negative 2x squared. Remember, we're flipping the signs. This becomes a positive 2x squared. Negative 4x plus 2x is negative 2x. 0 comes down. Negative 2x times x is negative 2x squared. Negative 2x times x is negative 2x squared. Negative 2x times negative 2 is positive 4x. Switches all the signs, positive and negative. Negative 4x plus 1. And then times by negative 4. Negative 4 times x is negative 4x. Negative 4 times negative 2 is going to be positive 8. We have to switch the signs though, so it's going to be negative 8. 1 minus 8 is negative 7. Negative 7 divided by x minus 2 for the remainder. And there you have all that.